Hi guys, welcome back to my channel Pirai Academy. In the series of data structure playlist, today we are going to see about code implementation of circular linked list. Okay, if you haven't saw about the logical implementation, just go and watch it first so that you can understand this. Okay, so I have taken C++ code. Meanwhile, if you want the Java or Python code, you can search in the description. I will be given in the description. Okay, fine. So see here, for any linked list we want a node, right? So here we want a node, so we have a class node. Inside that I will be having two data members. What are those? One is data, another one is next address. Okay, now there will be a constructor to initialize the value to the data. Okay, and the null will be initially pointing to the null pointer. That's it. Okay, now this is going to be the important class. This is going to be the class that's going to be implementing the circular linked list. So see here, inside that also we having two data members. One is head, one is tail. Okay, and then these going to be the private, and in the constructor we are going to initialize the head and the tail as a null, which means the linked list is empty initially. Now let us get into the functionality. First functionality is insert at beginning or start. Here we will be getting only the value as a parameter. Now I will be creating a new node with respect to the value they have given in the parameter, and also I want to check whether the head is equal to null pointer, which means the linked list is empty. If it is empty, I want to point both the head and the tail to the new node and make the tails next to the head and then return there itself. That's it. Okay, if not, what should I do? I want to take the new node next as head first. Now head will be new node and tails next will be head, as I told in the drawing explanation. Now coming to the next functionality, insert at end. Here also they will be giving you the only the value. We want to create the node first, then we want to check whether the linked list is empty. If it is empty, do the same thing we have done in the insert at start. Okay, and then here comes the rest. If it is not empty, then what should I do? We want to first take the tails next and make that link to the new node. Okay, then tail is equal to new node. Now tail next going to be pointing towards the head. Can you understand this? Okay, now here comes the important functionality, insert at index. Here we want two parameters, one is value, one is index. Okay, now I want to check whether the index is valid, right? So first of all, I want to check whether the index is less than 0. If it is less than 0, that itself I will be telling that it is an invalid index. Okay, if it is equal to 0, then I want to insert at the start, right? So I will be reusing that functionality. And then if the linked list is empty, okay, then there itself I can tell that the linked list is empty, so we cannot have any indices. Okay, so these are all the edge cases. Okay, now here comes, I want to point a current pointer towards the head and take a count variable as 0 initially. Now I want to go up to what? If I want to insert at second index, I want to go one step. If I want to delete third index, I want to go 2 steps. So that's the reason why here I am putting like count is less than index minus 1 and current next is not equal to head. Up to this I want to go one by one. I want to traverse one by one using the current and make the count variable to add one by one. Okay, now if the current is equal to the tail, then what it signifies? After doing this traversal, if the current is equal to tail, what it signifies? We want to insert at the end. So instead of writing the code, we can reuse the functionality. And then if the count is not equal to the index minus 1, okay, then what it signifies? The index is out of bound. Can you understand this? Okay, now node star new node is equal to new node of val. Here I am creating a new node, and that new nodes next going to be the currents next, and currents next going to be the new node. Okay, and tails next is equal to head. That's it. Can you understand this? So this is the last thing we want to do. Now the next functionality is going to be delete at start. Okay, so here we want to check whether the linked list is empty. If it is empty, that's how I can tell the list is empty. If the head is equal to the tail, then it has only one element. At that particular point, I will be deleting that one node and I will be making that to null pointer. which means the linked list is empty. Okay, now temp is equal to head. If this both conditions are not satisfied, then we want to delete it, right? So first of all, temp is equal to head and head is equal to head dot next, sorry, heads next. Okay, now tails next is going to be the new head. Okay, now delete the temp, that's it. Okay, now delete at end. Here also I will be checking the same two conditions, whether the linked list is empty or the linked list have only one element. Then I want to do the same thing I have done in the delete at start. Okay, then here comes current is equal to head and I want to traverse up to the node which next node is equal to the tail, right? So that's the reason why I'm checking whether the current's next is not equal to the tail. If it is so, I want to traverse up to that. Then after traversing, I want to delete the tail node and my new tail will be the current node and tails next going to be the head because it is a circular linked list. Okay, now here comes another functionality called delete at index. So here I'll be getting the particular index as the parameter. Here also I want to check whether the linked list is empty. If it is empty, I will be returning it is empty. If the index is less than 0, that is I will be telling that it is an invalid index. And if the index is equal to 0, then which means I want to delete at start. Instead of writing the entire code, I'll be reusing the functionality. And here comes the actual code. So see here, I want to set current pointer to the head and count as 0 initially. Now I'm going to count up to what? Up to index minus 1, because if I want to delete the third index, then I want to stop at the second index, like that. Okay, and also it should be not out of range. That's the reason why I'm doing another condition like currents next is not equal to the head, which means it should be going up to the tail, it should not go again to the head. Okay, so these are the two conditions up to which I want to traverse and increment the count. Okay, now here comes a check for whether I'm going to delete the tail element. Okay, so here I want to check whether the current's next value is equal to tail. In this particular case, I want to delete at end. Okay, and here comes if current's next is equal to head, then at this point I can clearly state that index is out of bound, because see here I'm standing at the tail and I want to delete this next value. After tail there is no next value, it again goes to the head, right? So at that particular point I don't want to delete anything. That's the reason why I'm just giving out the printing, I'm just giving out the error message. Okay, now here comes temp is equal to current's next. Okay, now current next is equal to temp's next and delete the temp. That's it. So here I'm doing like the current next should be point towards the current's next. Okay, but current's next is going to be temp. That's the reason why I'm doing current next is equal to temp's next, so that a linkage will be between the next elements next. Can I understand this? That's the reason why I'm using this. Okay, and then at last I will be making the tail to point towards the head. Okay, fine. So here comes the display function. In display function it will be so simple. First of all, I want to check whether the list is empty. If it is so, then I will be printing it, and then in next step I want to take a temporary variable towards the head and I'll be just going on and traversing up to I reach the head as the head as the temp value. Okay, up to that I want to just print the data. That's it, and traverse one by one. For this, temp is equal to temp next, like that. Okay, and then here comes the destructor. In destructor I will be just I will be checking whether the head is equal to the null pointer. If it is so, that's how I will be returning. Okay, or else I will be taking a current pointer and pointing towards the head and moving on up to the tail. Okay, and deleting everything inside that. Okay, that's the only part I am doing inside the destructor. And here it is a main function. You can also use your own menu driven program. Okay, here I have written manually. There you can use your menu driven program for the user interaction. Okay, fine. So this is how we want to implement the circular linked list. And if you have any doubts, you can comment below. I will be commenting out the answers. And if you really like this video and subscribe to my channel. Don't skip any videos in this playlist, because all videos will be helpful once you are going into a competitive programming. Thank you.